Hello students, welcome back to the next module of our chapter called electrostatics. Now students, in this particular module, we'll be learning MCQs which are based on the capacity of parallel plate capacitor. Now students, we already know formula for capacity of parallel plate capacitor. What is the formula? Formula is epsilon naught Ka by D. Now using this particular formula, we'll be solving MCQs in this particular module, right? So let us start with the first MCQ. It says a parallel plate capacitor is to be prepared by using plates of same area of one of the dielectric given below. So here we are provided with the dielectric, value of K is given, and the distance of separation which is to be taken is also given, right? So for Teflon, K is equal to 2 and the distance of separation to be taken is 0.4 millimeter. For quartz, value of K is 3 and the distance of separation is 0.8 millimeter. And similarly, we are provided with values for glass and mica. And here we are asked which dielectric gives us the maximum capacitance. And the options are option A mica, option B Teflon, option C glass, and last option is quartz, right? Now let us analyze. Now students, see carefully, this is nothing but a parallel plate capacitor, and for parallel plate capacitor, capacity is given by C is equal to Ka epsilon naught by D, right? Where K is dielectric constant, capital A is area, and epsilon naught is the permittivity of free space. Now students, we know that epsilon naught is constant because it is having a fixed value of 8.85 into 10 raised to power minus 12. Now in this case, as area of each plate is same, so I can say area is also constant, right? Now see this particular formula carefully. Epsilon naught is constant, capital A is constant, so I can say C directly proportional to K by D, or I can say C depends upon K and D, right? Now take this particular thing ahead. Now if as C is directly proportional to K by D, I can say greater the value of K by D, greater will be the capacity. So we'll calculate K by D in each of the following cases, right? Now let us move further and let us calculate K by D, right? Now for Teflon, K by D will come out as 2 upon 0.4 millimeter, and this will become 2 upon 4 into 10 raised to power minus 4, and this will come out as, if you solve it, this will come out as 5 into 10 raised to power 3. Right? Now let us move further. Let us calculate it for quartz. This will become 3 upon 0.8 millimeter, right? Which will come out as 3 upon 8 into 10 raised to power minus 4. And this will come out as 3.75 into 10 raised to power 3. Right? So let us update that as well. Now for glass, it will come out as 4 upon 1 millimeter. Right? So this will come out as 4 upon 1 into 10 raised to power minus 3. And this will become 4 into 10 raised to power 3. So let us update that as well. And lastly for mica, I can write K by D as 5 upon 1.2 millimeter, which can be written as 5 upon 1.2 into 10 raised to power minus 3. And if you calculate this, you will get 4.16 into 10 raised to power 3. Right? Now, as we have updated the values of K by D, now see, in which case the value is maximum? Yes, for Teflon, the value is maximum. Right? And as K by D is maximum in case of Teflon, I can say capacity is also maximum in this particular situation. So which option is correct? Yes, option B is the correct answer. Now let us move further. Let us start with the second MCQ. It says the capacity of parallel plate condenser is 12 microfarad. What is its new capacity? If the separation between the plates is doubled and the area is halved. And the options are option A 1.5 microfarad, option B 3 microfarad, option C 6 microfarad, and last option is 8 microfarad. Now students, here we are provided with the capacity of parallel plate condenser. So let us consider it as air capacitor. So I can consider C, it is equal to C air, and the capacity for air capacitor is given by epsilon naught A by D, and the value is 12 microfarad. So I can write C, it is equal to C air, it is equal to epsilon naught A by D, and it is equal to 12 microfarad. So here we are provided with value of epsilon naught A by D, and it is equal to 12 microfarad, right? We are supposed to find out the new capacity. So let's say my new capacity is C1. If the distance between the plates, right, or the separation between the plates is doubled. So let's say my new separation is D1 and it is twice of D, where D is the initial separation, right? And in this case, area is halved. So let's say my new area is A1 and it is equal to A by 2. Right? So here we are provided with values of D1 and A1, and we are supposed to calculate the value of C1. We also know value of epsilon naught A by D, right? It is equal to 12. Now using these values, we are supposed to calculate value of C1. Now let us start with the solution. Now students, we know that for air capacitor, capacity is given by C is equal to epsilon naught A by D, right? So for second capacitor, for second situation I can say C1 can be written as epsilon naught A1 upon D1. Now we know value of A1, right? What is value of A1? So this can be written as, what is A1? A1 is A by 2, so this will become epsilon naught into A by 2, right? Upon value of D1. What is value of D1? It is twice D, so this will become twice D, right? So if I calculate this, I'll get epsilon naught A upon 4D, right? And this can be written as 1 by 4 into epsilon naught A by D, right? Now let us move further. So 1 by 4. Now what is value of epsilon naught A by D? Now see the above table, it is equal to C. So this will become 1 by 4 times C. And what is value of C? It is 12. So this will become 1 by 4 into 12, and this will come out as 3 microfarad. So students, if the distance of separation is double and the area is half, my new capacity will be 3 microfarad. Yes. Now see the options carefully. Which option is matching? Yes, option B is the correct answer, right? So students, in this particular module, we have covered 2 MCQs which are based on the concept of capacity of parallel plate capacitor. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.